Hello, everyone. If you've ever tried to train a large AI model like Llama or Stable Diffusion, you know the struggle. It requires massive supercomputers, huge amounts of memory, and it costs a fortune. Imagine you want to teach an AI a new skill, like understanding medical reports or speaking like a pirate. Traditionally, you'd have to retrain the entire brain of the model. That is slow and expensive. But what if I told you there's a way to teach an AI new tricks without touching its original brain? That technology is called LoRA, or low-rank adaptation. Let's break down exactly how it works. To understand LoRA, let's use a simple analogy. Think of a massive AI model, like ChatGPT, as a giant, finished encyclopedia. If you use the old method, called full fine-tuning, and you wanted to add a chapter on modern slang, you would essentially have to reprint the entire encyclopedia just to add those few pages. That's a waste of paper and ink, right? LoRA takes a smarter approach. Instead of reprinting the book, LoRA simply writes the new slang words on a sticky note and places it on top of the relevant page. The original book stays exactly the same. It's frozen. But when you read that page, you see the sticky note combined with the original text. That sticky note, that is your LoRA adapter. Now, for my technical students, here is what's happening under the hood. Inside an AI, knowledge is stored in giant grids of numbers called weights. Let's call this big grid W. In standard training, you update every single number in W. But in LoRA, we freeze W. We don't touch it. Instead, we create two tiny matrices. Let's call them A and B, that represent the changes we want to make. Because A and B are very small, or low rank, they are incredibly fast to calculate. We train only these tiny matrices. Let's look at a real-world example. Say we have a standard AI assistant, and we want to turn it into a pirate bot. Without LoRA, you would retrain the whole model. You'd end up with a file that is 20 gigabytes in size. And worse, that model can only speak pirate. You lost your original assistant. With LoRA, you keep your original AI. You just train a tiny adapter file that is maybe 20 megabytes. When you want a pirate, you plug in the pirate LoRA. When you want a coder, you plug in a Python LoRA. So, why is this revolutionary for developers and students? 3 reasons. Speed. You can train a LoRA on a gaming laptop in an hour, rather than a server farm in a week. Storage. You can store hundreds of different skills on a USB drive because the files are tiny. Flexibility. You can swap skills instantly without reloading the massive base model. LoRA has democratized AI. It allows individual developers and researchers to customize billion-parameter models without a billion-dollar budget. If you found this explanation helpful, please hit that like button and subscribe for more simple explanations of complex AI concepts. I'll see you in the next class.